Alright, today we're looking at exponential graphs. So graphs of exponential equations. We're going to start out with y equals 2 to the x. And remember, you can graph any equation at all as long as you're able to plug in values of x to get values of y. So we can start with, for example, -2, -1, 0, 1, and 2. Just plug in those x values, get our y values, and then plot those points. So we know 2 to the -2 gives us 1/4, 1 over 2 squared. We know 2 to the -1 is 1/2. 2 to the 0, anything to the power of 0 is 1. 2 to the 1 is 2, and 2 squared is 4. So we can plot these points. So we've got -2, 1/4. Something in here. We've got -1, 1/2. We've got 1, 0, 1, 2, and 2, 4. By the way, 2 cubed is 8, so that brings us all the way off our graph, right? 4, 4, 5, 6, 7, 8. No, it doesn't. It's right here. Okay, so we have something like this. Okay, so some things that you should notice about an exponential graph. There is a horizontal asymptote. This one happens to be at y equals 0. We'll talk about other things as well as we graph different types of exponential equations, but this one, it does show exponential growth. Notice it's not linear. Over time, it's exponentially growing. It's growing twice as much every single time. So let's also look at 3 to the x. Again, we can use -2, -1, 0, 1, and 2 for values of x. We plug them in. We get 1/9, 1/3, 1, 3 to the 1 is 3, and 3 squared is 9. So okay, so something like this. So in comparison to our last graph, we've still got a horizontal asymptote at y equals 0. Notice our function grew even faster compared to y equals 2 to the x. If you look at our last example, we had to go when x equals 3, y equals 8, whereas when x equals 2, here, y already equals 9. So it's growing even faster. And that's all, of course, due to the base that we were working with. So the bigger the base, the faster your exponential growth. So 3, of course, is larger than 2, so our exponential growth is going to be even faster. Okay, so we're going to again graph y to the 2x, and then we're going to compare it to two other graphs. So y to the 2x, it's good for you to keep graphing this so that you're comfortable with it. We've got 1/4, 1/2, 1, 2, and 4. Okay, so this is, oh, this is y equals 2 to the x. Should actually go through here. Okay. And we want to graph y equals 2 to the x plus 1. So let's use this t-chart here. We can still do okay, so when we plug in -2 to this equation, we've got 2 to the -2, which is 1/4, and then plus 1. So we've got 1 and 1/4. We've got 2 to the -1, which is 1/2, plus 1 is 1 and 1/2. 2 to the 0 is 1 plus 1 gives us 2. 2 to the 1 is 2, plus 1 gives us 3, and 2 squared is 4, plus 1 gives us 5. So then we can graph each of those points. We've got negative 2, 1 and 1/4. We've got negative 1, 1.5. We've got 0, 2, 1, 3, and 2, 5. Okay, now our horizontal asymptote is at y equals 1. Okay, do you see the pattern? So of course, the plus 1 has moved our graph up 1, just like you would expect, just the same as what we were looking at last unit. And of course, it moved our horizontal asymptote up 1. Normally, we would expect, as we saw with y equals 2x and with y equals 3x, our horizontal asymptote was at y equals 0. So it's this plus 1 has moved our horizontal asymptote up 1. So of course we could do the same thing with 2 to the x minus 2. We could plug in our x and y value. We could plug in our x values and get our y values, plot our points. But let's anticipate what these changes are going to be. So we've got minus 2, which means we're going to have a horizontal asymptote at y equals negative 2. Okay, if you look at y equals 2 to the x, notice 2 to the power of 1 is going to be our y-intercept. So that's just going to be moved down to. So it's going to still be 1 above our vertical asymptote. Yeah, and same with this point. We've got 2 to the 1. We expect that to be 2. So that's, again, if we go over 1, we're going to have a point 2 up from our expected horizontal asymptote. We know 2 to the 2 is 4, and so if we go over 2, x is 2, we're going to go up 4 from our horizontal asymptote. So not up 4 from the x-axis, but 4 from this horizontal asymptote. And we could even go over 3 and up 8 from our horizontal asymptote. Okay, so we've got a graph that looks something like this. So it's the same as y equals 2 to the x, it's just gone through the transformation where it's been moved down to. And as a result, that moves our horizontal asymptote down to. Okay, again, we'll want to graph y equals 2 to the x, so we should be experts at that by now. This is y equals 2 to the x. If we graph the graph y equals 2 to the x plus 2, so again, we can plug in x values and plot our points. So we can use negative 2, negative 1, 0, 1, and 2. Okay, so x equals negative 2. We're plugging that into this equation here. So negative 2 plus 2, we're going to do that first. That's 0. We know 2 to the 0 is 1. Negative 1 plus 2 gives us 1. 2 to the 1 is 2. 0 plus 2 gives us 2. 2 to the 2 is 4. This is 2 to the 8, which is, or 2 to the 3, which is 8. And 2 to the 4 is 16. Okay, so negative 2, we've got 1. Negative 2, 1. Negative 1, 2. 0, 4. 1, 8. And 2, 16 is off our graph. So you can still see we've got this horizontal asymptote at y equals 0. What's happened though? Well, we can see that this point, which is up 0, has shifted from here 1, 2, 2 to the left. That looks familiar, hopefully. That is the same as last unit when we were looking at transformations. And remember, we said if something was inside the brackets, it would affect x, and it would do it backwards than what we expected, the opposite of what we would expect. So again, this is affecting x. Even though it's not in brackets, it's in our power, and it's in our exponent. So that exponent, anything within that is going to affect x. And what it did there is it moved our graph left. So the opposite of what we might expect from a +2, right? So it's the same exact graph, it's just gone through the translation of moving left 2. And then we've got, oh, I skipped one, didn't I? Okay, let's graph this one. As you can expect, we've got 2 to the x minus 1. That's going to move our graph, everything to the right 1. So y equals 2 to the x minus 1. That's the quantity x minus 1. Everything is going to the right 1. So we've got the point 0, 1, and y equals 2 to x. That's just going to move to the right 1 and become 1, 1. This one moves right 1 as well. The point 2, 4 becomes 3. 1, 2, 3, 4. And the point 3, 8 becomes 4, 8. And we've still got our horizontal asymptote of y equals 0. Y equals x2 to the x minus 3. Of course, we expect that to move right 3. So again, we're moving each of these points. Normally we have 0, 1. We're going to move that right 1, 2, 3. We normally have 1, 2, which we're going to move right 1, 2, 3 here. We normally have 2, 4 here. So 1, 2, 3 is going to be here. And we normally have 3, 8. 3, 8 is here. 1, 2, 3. That becomes 6, 8. Okay, so we still have our horizontal asymptote of y equals 0. We've just moved everything to the right 3 points. Same as y equals 2 to x, just moved to the right 3. Okay, 2 to the x and 2 to the negative x. 2 to the x. Okay, we've got 2 to the x and 2 to the negative x. So as you can, well, okay, let's just go through these. We've got negative 2, negative 1, 0, 1, 2. As our x values, we're going to plug those into this equation and calculate what our points will be. So we're going to plug in negative 2. We'll make it negative, which is a positive 2. So we have 2 to the positive 2, which is 4. We'll plug in negative 1. It becomes positive. So we have 2 to the 1, which is 2. This is 2 to the 0, which is 1. 2 to the negative 1 is 1/2, and 2 to the negative 2 is 1/4. So we have negative 2, 4. We have negative 1, 2. We have 0, 1, 1/2, and 1/4. And of course, we have this point here. Okay, so horizontal asymptote, so y equals 0. What's happened though? Well, we've had a reflection over the y-axis. And that makes sense because look, it's a negative x, right? When y equals, when we have the mapping xy goes to a negative xy, that's going to be a reflection over the y-axis. So if you think about it, normally we have the point 1, 2. And look, we've just made that negative. So now we have the point negative 1, 2. And we have this y-axis reflection. Okay, some more transformations here. We've got, again, y to the 2x, 4, and 8. Okay, so we want 3 times that. Okay, x values in, we've got 1/4 times 3 is 3/4. This will be 3 over 2. This will be 3 times 1, which is 3. 3 times 2 is 6, and 3 times 4 is 12. Three over 2 is the same as 1.5. We've got 0, 3, 1, 1, 2, 3, 4, 5, 6, 2, and 12 is off our graph. Okay, so something like this. So what's happened to our 2 to the x? Well, it's just gone through a vertical stretch. Again, just like you would expect if we multiply our function, if we multiply y by 3, we're vertically stretching our graph by 3. So this is a vertical stretch of 3. In y equals 1/2 times 2 to the x, we're doing a vertical compression of 1/2. So that's this equation here. So 2 to the x, every y value is just going to be multiplied by 1/2. So the x value will stay the same. Instead of 0, 1, we'll have 0, 1/2. Instead of 1, 2, we'll have 1, 1. Instead of 2, 4, this point here, we'll have 2, 2. Half of 4 is 2. Instead of 3, 8, we'll have 3, 4. So half of everything. So it just doesn't rise nearly as fast. Okay, so vertical stretch, vertical compression, same as you would expect last unit. Okay, negative 2 to the x, that is going to be an x-axis reflection. And just to show you that, so we plug in negative 2 for x, we get 1/4, and then we're going to make that negative. So negative 1/4. This will be negative 1/2, this will be negative 1. 2 to the 1 is 2, and we make it negative, and 2 squared. Remember, if the negative is not in brackets, you do the power first, and then you make it negative. So this is telling us do 2 squared, and then make it negative. So 4, and then make it negative. So we have negative 2, negative 1/4, negative 1, negative 1/2, 0, negative 1, 1, negative 2, and 2, negative 4. So kind of like that. Okay, so same graph, congruent anyhow to y equals 2 to the x, it's just gone through an x-axis reflection. For time's sake, I'm not going to continue to graph all of these. Let's talk about the transformations though. This one here, we're going to have a vertical stretch of 3 and an x-axis reflection. I'll graph this one quickly. So we normally expect 0, 1, so we're going to have 0, negative 3. We normally have 2 to the 1 is 2, so we're going to have 2 of 1, sorry, 1, 1, 2, and that's here, so double or triple that, we've got negative 6. 2 is 4, times 3 is off the graph. So we've got something like this. And that is y equals -3 times 2 to the x. Okay, so again, x-axis reflection because of the negative in front of our function, and a vertical stretch. It's growing even more negative than we would expect 2 to the x to grow. Okay, this is just a summary of what I've talked about. So in general, if we're talking about this graph, so some value a times a base of b. So b, that base controls how steeply the graph increases or decreases. When we looked at 2 to the x versus 3 to the x, 3 to the x increased a lot faster because the base was bigger. C controls the horizontal translation. Notice here you're given x minus c. So for example, if that happens to be x plus 3, we know that moves 3 to the left. If it happens to be x minus 2, we know that moves 2 to the right. Okay, so this is the exponent itself. The D controls vertical translation, so whether it moves up or down, and that's exactly as we would expect. If it's plus 3, it's going up 3. If it's minus 3, it's going down 3, just like in the transformations we looked at last unit. Okay, this part, this is where we're talking about A and B together. The idea of increasing, by the way, means that our graph is, as we go from left to right, our graph is going upwards. Okay, so if A is positive, so if this value is positive, and if B is greater than 1, okay, so a number greater than 1, then we're looking at an exponential function of this form. Okay, that's what, for example, y equals 2 to the x looks like that because we have 1 times 2 to the x. 1 is positive and 2 is greater than 1. Okay, if A is positive, okay, so A is still positive, and B is a fraction between 0 and 1. So for example, B is equal to 1/2. We didn't look at any of this form, but this is just kind of a bit of extension, to be honest, and a bit for your own information. So if we were to have 1/2 to the power of x and say times 1. 1 is positive. So that graph would look something like this. Okay, this is called exponential decay, and we'll look at that more in the future. So this is, notice that graph is decreasing, and the idea of decay means it's getting smaller over time. Okay, if A is negative, so now we're looking at A being negative, okay? And B is greater than 1. So, for example, -2 to the x, we looked at a graph of that. It has this form. It's decreasing. This, again, is, decreasing function over time. It's getting smaller over time. If A is negative and B is less than, B is between 0 and 1. Okay, so for example, -1/2 to the x. That is going to be an increasing function. And again, we didn't look at any of that kind, but it's going to look something like this. The reason, by the way, that it's increasing is, I mean, normally you would think, okay, it's negative, so that means we have an y-axis, an x-axis reflection, right? But actually we have two kinds of reflection here. We have negative out in front, so that's an x-axis reflection, and look, we can write 1/2 as 2 to the -1. So that's 2 to the -x. So we've got an x-axis reflection and a y-axis reflection happening. But again, that's a bit of an extension, so don't stress if that's that's a bit much right now. Just some theory anyhow. Okay, so what is important is that you're able to draw the following graphs, and that you recognize the kind of transformations that they will be going under. So I'm just going to talk about each one. It's important that you're able to draw them. Okay, so letter A, we can see that this is a vertical transformation. It's going to go down 2. Letter B, this is to the negative x, so that's a y-axis reflection. Okay, and you need to be able to recognize these as well. I'll just say it for the first part. I'll let you think about it for the second one. Letter C, we're moving right 2 here because our change is happening in our exponent. It's -2, so whatever happens to x is, we expect the opposite, so it's going to move right 2. And then finally, letter D, this is going to be a vertical stretch. Okay. Okay, so if you can pause the video, if you can actually graph those, that would be ideal. So those are the second part. Where are the first ones? Here. Here. Okay, so those are your solutions, and here are the questions. So if you can please graph each one of those, make sure you understand the transformations. Thank you.